Hello friends, today we will discuss chapter number 2 of class 10, acid, bases and salts. So we will discuss it one by one, first acid, bases and then we will discuss about salts. So as we all know that we are surrounded by these chemicals, acid, bases and salts. So the very first thing that acids are sour in taste. Sour means khatta. They are sour in taste. So we all have tasted, we know this amla and tamarind, imli, and then we have tasted lemon, then apple, everything. So all of them contain some form of acid. So they are sour in taste. Second, they turn blue litmus to red. And there are various examples like we have citric acid. Citric acid is present in citrus fruits like oranges. Then we have lactic acid. It is present in milk or milk products. Then we have hydrochloric acid, H2SO4. One thing that I should let you know that organic and inorganic acids. Organic means anything which is natural. So all these types of acids, citric acid, then we have lactic acid, then we have malic acid in apple, we have oxalic acid in tomatoes. So all these acids which occur in nature or which they are obtained from nature are called organic. And then we have inorganic, or another name for inorganic is mineral acids. So mineral acids which are HCl, H2SO4, and then we have HNO3, etc. So these are mineral acids. So these are example. We all know these Tampa, Sprite, so Coca-Cola. So all of them contain carbonic acid. Then we know these batteries, inverter batteries, they are made up of sulfuric acid. Tartaric acid is present in wine. In fertilizers, we have nitric acid. In our stomach for digestion, we have HCl, hydrochloric acid. Salicylic acid is present in aspirin. Nowadays, we are having salicylic acid face wash. So entire internet is full of salicylic acid because it is a good exfoliator. Then we have acetic acid, vinegar, citric acid. We all know citrus fruits. Then there are various, basically all these elements, all these acids which are used in labs. So some naturally occurring acid that I told you, vinegar contains acetic acid. Citric acid is present in citrus fruit. Tamarind, imli, it contains tartaric acid. Then we have tomato, so it contains oxalic acid. Milk or milk product, it contains lactic acid. We have lemon, so it is having citric acid. And testing, this question is very important. And testing or bee sting, madhumakhi or nettle sting, it contains methanoic acid. Methanoic means one carbon. So formula for this one is HCOOH. And again, nettle sting, it contains methanoic acid. So difference between methanoic and ethanoic. Where is this vinegar, acetic acid? This is also called ethanoic acid. Only difference in methanoic and ethanoic is that this ethanoic acid contains CH3COOH, whereas in this we have HCOOH. Here we have only one carbon, here we have two carbon, this one and two. That is the difference. Both of them, this one, acetic acid and uh, this methanoic acid, belong to the same family of carboxylic acids. Then we have bases. Bases are bitter in taste. Bitter means they are, you know, like in Hindi we say kasela or bitter in taste, or soapy in touch, slippery in touch, and they changes blue color of the red litmus to blue. Not this one. They turn red litmus to blue, R to blue. Common examples are washing soda, baking soda. So we all use this soap. So soaps are nothing, just long chain of fatty acids of sodium hydroxide. Then we have detergents. Then we have a lot of bases which are being used in lab. Then we have cement and these hydroxides. Toothpaste, very good example that we will discuss later on in pH sensitivity and pH importance of pH. Then we have ammonia, one of the most prominent, I would say, the compound that is being used over the decades, even right now. So the very famous reaction is H2 plus, or I should write it like this, 2N2 plus 3H2, it gives 2NH3. This process is called Haber process for the preparation of ammonia, very important compound. Okay, so just visual representation. So we have litmus paper. In acidic medium, it is red. In basic medium, it is blue. Methyl orange, these two are indicators. So methyl orange is red in acidic medium and yellow in basic medium. This phenolphthalein is very important indicator. So it is colorless in acidic medium and very bright pink in basic medium. Next category of indicators that we have, so these are all are called uh, universal, yeah, not you can say universal or chemical ones, chemical chemical based indicators, chemicals indicator. Then we have olfactory indicators. Olfactory, this word means odor or smell. So we will discuss, we have onion extract, we have vanilla. So the next slide. So olfactory indicators are based on smell, odor. So they change their smell in acidic or basic medium. So we have onion, and then cloves, clove or clovile, long. Then we have vanilla or vanilla extract. So we all know this vanilla flavor. So it comes from a compound called vanillin. So these substances, these are also indicators and they change their behavior. So in acidic medium, their smell increases. Yes, it is. So in acidic medium, their smell enhances, whereas it goes away or it diminishes in basic medium. So we all know the typical smell of uh, these cloves or onions. So their smell enhances in acidic medium and decreases or diminishes in basic medium. So since these are based on smell, so they are called olfactory indicators. Okay, so now let us suppose we have three different test tubes having three different chemicals filled in it. So how will you determine which one of them is acid or base or neutral? So the best thing is in these three test tube, step one, the base test. So to test a base, what we have to do? Dip red litmus into all these three. So one by one. So any solution which turns that red litmus into blue is going to be your base. And the second part is acid test. So again, dip blue litmus in all these three one by one. So the solution which changes the color of the solution to red, that will be the acid solution. And the third one you can easily eliminate. So basically that test tube which causes no color change. In this case, no color change because this is just simple water. So no acid or basis is there. So it will have no effect on the litmus test. So in this way you can distinguish. Okay, this is very important. So the main thing behind acid or base is the power of ions. So you should know that acids are the substances which release H plus. Acids are the substances which release H plus, and bases are the ones which release OH minus. So this theory was given by Arrhenius. Arrhenius. So this is the rule of ionization. So acids produce H plus, and when they combine with water, it becomes H3O plus, whereas bases produce OH minus. In this case, water is the main factor. Water is the catalyst, because if any acid, it is in its dry form, we have dry HCl. Dry HCl, it has no H plus ion. Since why it is having no H plus ion? Because it is dry. So what will be the effect of dry HCl on litmus paper? No effect, because it is not having any H plus ion. And since water is the catalyst, so the moment this HCl, dry HCl is dissolved in water, it becomes HCl aqueous, means liquid HCl. Now it is having H plus, so it turns it turns the color of the litmus paper from blue to red. So the thing is, the main factor is water behind any acid or base. So we have dry acid, it is written here, dry acid, it is inactive, whereas the moment we mix water into it, so you can see lot of OH minus and lot of H plus ions are there. So basically water is the catalyst. So conductivity increases because of uh, water. The moment water is dissolved, why it increases? Because now these ions are free. Ions are free. That means H plus and OH minus, whatever ions are there, these ions are free. And any type of conductivity is either because of free electrons or free ions. So if ions are free or electrons are free, then only conductivity is going to be there. So this simple question, conductivity inside. So distilled water is pure and lacks ion, preventing conductivity. So that is why distilled water is having no free ions. So it does not conduct electricity because it is not having free ion. So distilled water, it is also termed as deionized water. Deionized water. So this water is used to, clean that electrical components, because since it is having no free ions, so it will not conduct electricity. So this water is used to clean electrical components. Second part, in atmosphere we have lot of gases like carbon dioxide. So when during rainwater, water comes in form of rain, it combines with CO2 or SO3 or SO2 sulfur dioxide or sulfur trioxide. So many gases are there. So we have SO2, SO3. So when this water combines rainwater with those gases, so it becomes H2SO4. This is sulfuric acid. Here it forms H2CO3, carbonic acid. That is why it is termed as acid rain. Acid rain. Why acid rain? Because this water is combining with these gases to form acids. And that is why this type of rain, the first or second rain of the season, is very, very harmful. So rainwater dissolves atmospheric CO2 to form acids, releasing ions that conduct electricity. So these means acid rain, it conducts electricity. Okay, now the core part of the chapter is how do acids and bases react with metals. So even in the last chapter we have discussed this part. In which part? Displacement reaction. How? Because when any acid reacts with metal, so it displaces the less reactive one. So we have ZnSO4, sorry, ZnSO4 plus H2. So we already know, we have this idea. Let us see how. So acids react with metal to form salt and hydrogen gas. So this is all we know. The same reaction, zinc plus HCl. So since zinc is more reactive, so it will displace hydrogen. Now how hydrogen can be confirmed? You already know, pop sound. So when a burning candle, it uh, bring it near to the test tube and it gives a pop sound. Similarly, we have Fe plus H2SO4, so it gives FeSO4 and H2. So what you have to remember, general reaction is this one. Acid, when they react with metal, they give salt and hydrogen gas. Similarly, bases also react with metal to form hydrogen and this salt. So bases, they react with metal to form salt and hydrogen in a similar way. So we have again NaOH plus zinc, so it forms Na2ZnO2. This is called sodium zincate. Sodium zincate, in a type of salt. So again, a salt is formed and hydrogen gas is released, which can be confirmed with pop sound. So these two are the general reactions. In both of them, it reacts in a similar way. So this already we have discussed in class, sorry, in chapter 1. So zinc plus HCl, it gives H2 gas, and H2 gas, very bright pop sound. So it burns with pop sound. Okay. Second, this part is again very important. How do metal carbonates and bicarbonates react with acids? So first you should know what is carbonate and bicarbonate. So carbonate is this one, CO3, and the charge is 2 minus. Bicarbonate is HCO3 minus. This is the difference. This is bicarbonate and this is carbonate. So how metals, metal carbonates and bicarbonate react with acid? Similarly, both of them react in a same manner. So metal carbonate and bicarbonate, they react with acid to form salt, water, and CO2. This part is very important. CO2, it releases CO2. So we have two types of reactions. So you can see this is carbonate, sodium carbonate. So we have sodium carbonate, then acid. So it forms salt, water, CO2. So we already know that acid and base react, acid plus base react to form salt and water. So same thing, because these carbonates are basic in nature, this is acidic. So acid base reacting to form salt, water. One part is extra, which is CO2. And from where this CO2 is coming from? From this carbonate, from this carbonate. So similarly, when any bicarbonate reacts with HCl, so again it gives salt, water, and carbon dioxide. And how this carbon dioxide, evolution of carbon dioxide can be confirmed. So when this carbon dioxide, I told you in previous chapter, when this carbon dioxide passes through slagged lime, CaOH whole twice. So you remember whitewashing reaction, that is used for whitewashing. So it becomes CaCO3. Same reaction. So it is also called lime water. Lime water means slagged lime. So when this slagged lime reacts with carbon dioxide, which is present in atmosphere, so after 2 or 3 days, it becomes calcium carbonate and it releases water. So in this way, again, this reaction, general reaction, you need to know metal carbonates and bicarbonate, they react with acid to form salt, water, and carbon dioxide. This very simple phenomena you must have observed whenever you pour a packet of Eno in the water, so it it fidges, it gives fidge, and that fidge is used to treat that um, acidity. Similarly, when you put this lemon, 1 or 2 drop of lemon on Eno, so you will observe effervescence. Effervescence. That means that sound of fatfadahat, effervescence. It gives bubbles. So in a similar way, why this reaction is happening? Because Eno is also a type of, it also contains a form of carbonate. So when carbonate, it reacts with any acid, citric acid, or any form of acid, so it gives fidge, and that fidge is because of carbon dioxide, because carbon dioxide is releasing. Okay, so this already we have discussed in chapter 1, acid carbonate contact. So when this gas CO2, it releases, so if you pass this CO2 from the lime water, so it forms, it becomes milky white. Milky white. So that milky white part is nothing but the calcium carbonate. Now, this already we know, this CaOH whole twice, when it passes with the CO2, so we get calcium carbonate, this one. But main important part is this one, the excess twist. This is important. Now, the moment you pass CO2 with this calcium hydroxide, it converts to calcium carbonate. But if you keep passing on that CaCO3, sorry, that CO2, carbon dioxide from the lime water, again it will change from milky white to colorless. Why? Because if the amount of CO2 is more, so passing excess CO2 through milky solution turns perfectly clear again. Why? Due to formation of soluble calcium bicarbonate. Now this carbonate is becoming bicarbonate if you pass excess CO2. So again it will become colorless from this milky white part. So this you need to know, excess twist. Okay, next we already discussed this part. How can we detect this carbon dioxide? So basically when carbon dioxide is passed through calcium hydroxide, it gives calcium carbonate. And when you pass this calcium carbonate excess through this, again it becomes colorless. So this part is colorless because of formation of calcium hydrogen carbonate, bicarbonate. This part is important. Then this reaction, we all know, neutralization reaction, how acid and bases react with each other. So when any acid or base combines, so this is the base, this is an acid, so they form salt and water. Any type of reaction, you can take any type of base, any type of acid, it will always form salt and water. So this reaction is called neutralization reaction. Very important reaction, and it 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 is very important for the generalization of any reaction. Then in the first chapter itself, I told you the nature of metal oxide. So metallic oxides are basic in nature. Always remember, metallic oxides are basic in nature. So since it is a base, so when it reacts with acid, so again you know that acid and base, they will form what? Salt and water neutralization reaction. So we use tamarind, lemon, etc. to clean metal vessels. So you must have observed this is a plate which we use in temples. This copper plate or copper, that spatula or the tiny lota. So it get tarnished over a period of time and a green layer is formed. What is that green layer? That green layer is because of the oxide layer formed over it. So since it is a metal, so its oxide is going to be basic. So that is why when you rub this surface with either lemon or anything, tamarind. So since lemon and tamarind, they contain acid, and this metallic oxide is a base. So metal oxide is a base. What you are using, lemon or tamarind, is acid. So again it will form salt and water, and the moment you wash it with water, so this salt just goes away and we again get a bright surface of metal. So again, this is a example of neutralization reaction. The non-metal oxides. So again, we know that non-metal oxides are acidic in nature. Non-metal oxides are acidic in nature. If you ask me, can we prove it? So yes, we can also prove it. So how many oxides we know? We have non-metal carbon, its oxide is CO2. We have non-metal sulfur, its oxide is SO3. These are acidic. How can we prove it? Just dissolve them in water. So when you put them in water, so what we get? H2CO3. What we get? H2SO4. This is your carbonic acid. This is your sulfuric acid. So both of them are what? Acid. That is why non-metal oxides are acidic in nature. So again, when non-metal oxide they react with base, so again a reaction of acid and base. So what they will form? It form a salt and water. So every reaction is same. You just have to approach it in a conceptual way. So we have a oxide of calcium. So again, it is a Metal oxide, so it will be basic. This is a oxide of non-metal, so it is an acid. So acid and base again they are reacting, so form a salt, CaCO3 and water. That's it. So non-metal oxides are acidic in nature. This is very important. And metallic oxides are basic in nature. Okay, so this we all know. We should never keep these curd or any milk product in copper or any part. So this is the question. Why do traditional kitchens warn against mixing sour ingredients with exposed copper or brass? So why should we not keep these curd or anything made up of milk product in these vessels of copper and brass? So because when you store these foods in brass or copper vessels, so basically it over a period of time it forms a very dangerous, it undergoes very dangerous transformation. So this is the answer. It is written over there. Acids present in sour substances react vigorously with copper and brass. So this reaction dissolves the metal, forming poisonous metal compound that contaminate the food. So this the reaction that undergoes, it forms a very poisonous metal compound which is contaminating the food. That is why curd or anything made up of milk should not be kept in these metal pots. Okay, so the common question, what all acids have in common? So we all know every acid is having H plus or H3O plus ion with it. So whenever uh, any acid is having H plus ion, so when it dissolves with water, so water is like this. So in this case, oxygen is having a lone pair, so it absorbs or catches this hydrogen. So it forms O H H H, three hydrogen. And since this oxygen is giving its electron to this one, so it acquires a positive charge. And that is why we say this is HHH H3O plus. So this is called hydronium ion. So whenever any acid is dissolved into water, so water just protonates these H plus ion. So either you can write H plus or you can write H3O plus. So what all acids have in common is H plus and H3O plus. But there are many other compounds which do not have these H plus and H3O plus, but still they are called, acidic. They have acidic nature. What all bases have in common is OH minus ion, hydroxide ion or hydroxyl ion. So we know this NaOH, CaOH, MgOH whole twice, and so many are there. So what they have in common is hydroxide ion. It is responsible for all the chemical reactions or electrical conductivity. So this question was there in CBSE 2025. So the question is, design an experimental setup to demonstrate that alcohol and glucose contain hydrogen but are not categorized as acid. So also give the reason to justify this fact. That means you have to set up an experiment where you have to prove that alcohol and glucose, they contain hydrogen but they are not acid. So how can you prove it? So basically you can take a setup of this any type of electrolysis or any reaction of having electricity. So the first part you can set up this, so you can write this setup. So solutions of acids, what they have in common? They have H plus ion. So that is why they generate ions, and these ions conduct electricity. Bases have OH minus ion. So again these OH minus ion conduct electricity. But although these glucose C6H12O6 and alcohol C2H5OH, they have OH minus and H plus, but they do not generate ions. Why? Because they do not dissociate, they do not ionize. So since they do not ionize, they do not release H plus or OH minus. And since they do not release OH plus or OH minus or H plus, that is why there are no free ions. So you can write no free ions. And since there are no free ions, hence they cannot conduct electricity. So this question was there in 2025. Okay, this part is very important. Even students of higher grades 11th and 12th, they don't know this. So when any acid undergoes dilution, so what is dilution? Dilution is the process of adding adding solvent. Yeah, generally I would say adding water, H2O, to any concentrated solution. So the process of adding water to any concentrated solution is called dilution. So whatever acid we purchase from market is highly concentrated. So we need to dilute it before starting an experiment. Dilution process is very exothermic. Exo means it comes from exit. That means heat is released. Heat released. So whenever any acid is diluted, a lot of heat gets released. So the beaker or any vessel that we are using gets hot because the temperature rises so much. So the thing is, mixing an acid or base with water decreases the concentration of ions per unit volume, and that is why we call it as uh, dilution. So this part is correct. This part is correct. That means acid should be added to water. Acid should be added to water along with continuous stirring. Continuous stirring, that means we have to rotate it with a glass rod or something like. Uh, it must be, stirred. Why? Because dissolution should be proper and this process is exothermic, not the vice versa. You can never add water into concentrated acid. Suppose you are having any beaker full of acid and you are adding water into it. This should not be done because it will cause a huge blast. And the moment this beaker breaks away, so a lot of acid is going to be spilled over there, and this becomes very harmful. So this you should know, acid is to be added to water, not water into the acid. This is not allowed. Now the most important part is pH scale. So I hope you must have seen this pH strip. It is having these markings. It is a long strip. So either you will have from 0 to 7 or 7 to 14. So it basically it has from ranging from 1 to 14. In between, at the center, we have pH 7. pH 7 is neutral, and as we go beyond 7, it is basic. As we, as we go back to this from 1 to 4, it is acidic. So these are the examples. At pH 7, we have neutral. So we have pure water in this category. And then as you go left, we have a lot of acids. So gastric juice, that is HCl, then we have lemon, then apple, then tomato, then black coffee, then we have milk. So all these substances are, having acidic character. And as we go to the right side of this water, we have egg, baking soda, hand soap, ammonia, bleach, and concentrated alkalis like we have NaOH, KOH. So they have the highest pH. So its nature is basic, and as we move to this side, these are acidic. So this strip, this scale is called pH. pH, again, this word, this you will learn in class 11. There are a lot of calculations also. So this word pH, it comes from, I think, Greek or German. So it is called potenge dihydrogen. Potenge dihydrogen, that means power of hydrogen. And its formula is pH is equals to minus log of H plus. So this we use in higher grades. Okay. So this just I have discussed. pH less than 7 is acidic, pH 7 is neutral, pH greater than 7 is base. So we have basic nature. So can you write metal oxide? Metal oxides fall into this category. In this category we have non-metal oxides. So these are acidic. Okay, next. So pH, it is, very, it has a lot of impact. It has a lot of applications in our life. So human biology. So our body operates in between 7 to 7.8 pH. That means slightly basic. I would say mild or slight basic. So what is the natural pH of our body? So you can say it is slightly basic. But cancer cells, cancer cells, they have acidic pH, acidic pH. And based on this uh, acidic pH theory, we have a new, research, a lot of research is going on, that is called targeted drug delivery. Targeted drug delivery. So now, scientists are targeting these cancer cells. How they are targeting? Because normal cells, they have basic pH, whereas cancer cells have acidic pH. So they are just targeting the acidic, cells. So that is called targeted drug delivery. Then in digestive chemistry, again, it has a lot of applications. We all know stomach is having HCl, so which is used for the digestion. Excess HCl, it causes pain, which is called acidity, and this acidity is, neutralized by uh, various antacids, like we have milk of magnesia, and then we have a lot of, brands. So many names are there. We have Eno, we have Pantop, we have Pantop, we have so many tablets like ranitidine that comes with the name Gentech, although I think Gentech has been banned in US. I'm not sure about India, but the drug is ranitidine. So these are antacids which are used to, uh, you know, counter or cure acidity. Then dental integrity. This is very important. So because, nowadays we are consuming a lot of soft drinks. So everyone is obsessed with Pepsi, Cola, Campa. These are brands. So we have a lot of soft drinks. So again, all of them contain what? Carbonic acid. So all these soft drinks, they contain carbonic acid. And when these soft drinks, they reach to the enamel, or they touch the tooth enamel, so it just degrades the calcium phosphate. So the pH of the mouth decreases because of it, acidic nature of these soft drinks. So whenever, even when we sleep overnight, so the pH of inside our mouth, it falls below 5.5. So that means it becomes acidic, and that is why we need to, brush twice a day. Twice a day. Why twice a day? Because these toothpaste is basic in nature. Toothpaste is basic in nature, and when we sleep overnight, or when, we eat a lot of things, so because of that, those bacteria, the pH of mouth becomes acidic. So again, this acid and the basic toothpaste, they neutralize each other. So to neutralize the pH of our mouth, we need to brush at least twice, preferably thrice, but at least twice. And this chemical warfare, that, we have nettle sting, bee sting. So bee sting injects very harmful acid that is called methanoic acid, that we discussed in the first two slides, I think. So it releases methanoic acid, HCOOH. So it is a strong acid. So the affected area gets swelled up quickly. So in order to counter this, we have to apply baking soda to the sting side. Wherever it stings, we have to apply any form of base, either baking soda or even toothpaste. Sometimes it works to again neutralize the reaction. So this already we have discussed. Our body pH is this one, 7 to 7.8. Rainwater, because it is acid rain, so when pH is 5.6 or less than that, it causes acid rain, and acid rain is very harmful for agriculture, because plants, they need a specific pH for growth. That is why we need to maintain the soil pH. Our stomach produces HCl. Too much HCl causes indigestion, pain, irritation. So to get rid of this acidity, we use antacid like milk of magnesia, and I told you several drugs like Pantof, we have ranitidine, so many things are there. So this slide is just a picture that potato needs this much pH, 4.8 to 6.5. Carrot need this much pH. Onion needs this pH. Lettuce needs this pH. Tomato grows in this. Cabbage grows in this. So that means pH has a very crucial role in our everyday life. So I told you just this one, importance of pH in our life. The tooth enamel, that is calcium phosphate, gets corroded because of lot of acids produced by bacteria or soft drinks or the food particles. So to prevent this, we use toothpaste. Why? Because toothpastes are basic. So when we use these toothpaste, so basically we are doing a neutralization reaction. Even bees and ants, they inject that methanoic acid or formic acid. So we have to use either soap or toothpaste or baking soda to neutralize that affected site. So that is how chemistry is relevant in everyday life. This part is very important. I think CBSE has asked this year only, 2026. One question was there regarding pH of salts. So this table is very important. pH of salt. So now since we know that these salts are very important and how these salts are formed, these salts are formed by acid and base, so they give salt and water. So now we are studying about salts. So an acid, so when acid and base they react, they give salt. So any component which is strong, suppose acid is strong, so nature of salt would be acidic. If base is strong, nature of salt would be basic. If both of them are same, it will be neutral. So this table is very important. So look at this one. So this side we have acid component, base component, and nature of salt. So if both of them are strong, salt is going to be neutral. Example, we have a strong base NaOH, we have a strong acid HCl, salt is neutral, NaCl. Similarly, if both of them are weak, so again it will be neutral. So we have weak acid, vinegar, acetic acid, we have ammonium hydroxide, then this nature of salt is also weak. That means you don't need to think much in these two cases when both of them are strong or both of them are weak. Now, if the acid part is strong, salt will be acidic in nature. If base part is strong, salt will be basic in nature. So more than this, what you have to remember is the nature. If acid is strong, so HCl is a strong acid. And in this case, we know that base is NaOH is strong. So if HCl is strong, what is the nature of this salt? NH4Cl. That means this salt must be acidic. Why? Because it is coming from a strong base. Now, what is the nature of this salt? This must be basic. Why? Because it is coming from a strong base NaOH. So in this way, you have to predict. That means more than the forward process, what you need to remember is the backward. So if this is the salt, or if this is the salt, so you should know how to do retro. Retro means opposite. So NH4Cl, it is made up of two parts, one acid, one base. So NH4, it comes from NH4OH base and HCl acid. So you know that NH4OH is weak. This is strong. So since this is strong, so this must be acidic. because it is coming from a strong base. Okay, so this already told you, when acid and base react, they form salt and water, and this dilution process means dilution is very exothermic, so dilution must be done slowly, and acid is to be added to water, not the vice versa. So last part of our chapter is we know common salt is, what is common salt? We know common salt is NaCl, sodium chloride. How it is made? So it comes from NaOH plus HCl. So it gives NaCl plus H2O. So there are various chemicals which are made up using common salt. So common salt is sodium chloride. It is very important raw material. So it is used for the preparation of sodium hydroxide, bleaching powder, baking soda, washing soda, and many more. So we will discuss them quickly one by one. So the first part is sodium hydroxide. Again, 2026, this question was there. What is chlor-alkali process? This question. So chlor, this word, chlor comes for chlorine, alkali comes for NaOH. That means with this name, what you can remember, one product is chlorine, another product is NaOH. So you can see one product is NaOH, another product is chlorine. That is why the process is called chlor-alkali process. And using chlor-alkali process, what is the product that we get mainly is NaOH, because chlorine is gas, so it leaves the reaction mixture. So what we are left with, NaOH. So chlor-alkali process, it is a process to synthesize NaOH. Now see how it is, what is the setup. So look at this one. This side, this is a positive terminal. So on this side we have anode. This is a negative terminal. So this side we have cathode. Cathode is on right side, anode is on left side. So what is the, precursor or raw material for this? We have NaCl. NaCl means sodium chloride. This is called fresh brine. Brine solution means it is saline water, NaCl. So when NaCl, it goes inside this one, in this chamber, and when we pass electricity, so this NaCl decomposes into its component Na plus, then we have Cl minus, and since this is having water, so water also splits into H plus and OH minus. So how many ions are there? We have H plus, we have Na plus, we have Cl minus, we have OH minus. So these are the four ions that we have. Now, I will discuss it in a little deep. So if you are interested, please look into it. We have four different ions, H plus and Na plus, these two cations, and Cl minus and OH minus, these two anions. So this terminal, you can see, this one is positive, this one is negative. So I will say which, although I use this trick in grade 11, but I will tell you L O A P. So loop, it means left oxidation, anode, and this is positive. So this is the setup of any electrochemical cell, or where do we carry out electrolysis. So you can check on left side, this one, we have oxidation, and this is anode, and LOAP. So this terminal is having positive charge. So just opposite of this one, you can write right reduction, cathode, and negative. So right side we have negative charge. Now, so since we have H plus and Na plus, these two are cations. So since these two are positively charged, so they should migrate towards which terminal? Negative terminal. Negative terminal is on the right side. So you will observe that towards negative terminal, we have two different types of charges, Na plus and H plus. Now, which one of them is fast? Which one of them reaches to the cathode earlier, Na plus or H plus? It is always H plus. Why? Because NaH plus is lighter. What is the mass of hydrogen? It is 1. What is the mass of sodium? 23. So since hydrogen is light, so it moves very fast. That is called mobility. Mobility. So H plus moves very fast in comparison to sodium. So H plus comes to this electrode quickly. So that is why you are having H2 here. So sodium remains in the solution. ये यहीं रह जाता है. Why? Because it is slower. Why? Because it is bulky, having high mass. That is why fitness is important. So less mass, more higher movement, more flexibility. So since sodium is heavier, so it remains in the solution and H plus goes towards electrode. Again, on this side, positive side, we have two ions, Cl minus and OH minus. So in this case, Cl minus is having more preferential discharge because of more reduction potential. So Cl moves to this side, that is why we are having Cl2 here. That means again in this case OH minus is left in the reaction. So this side we have Na plus, this side we have OH minus. So ultimately when these two are left, so they say चलो हम साथ में ही combine होते हैं, so they combine to form NaOH and NaOH is the product. Okay, so I will write it quickly. On the anode, what reaction is occurring? Anode is on the left side. So at anode, we are having chlorine. So two chlorine ions, they release in form of Cl2 and they release two electrons because it is having two negative charge. So they release two electrons. On the cathode side, what we have is hydrogen. So hydrogen is H plus. So two H plus, they attract these two electrons. So they accept these two electrons released by chlorine and it becomes H2. H2 एक गैस और Cl2 दूसरी गैस. So these two gases Cl2 and H2 are released and what we are left with is Na plus and OH minus. So these two combine to give NaOH and this is the process for the synthesis of NaOH, chlor-alkali process. Same, just a schematic representation. So we have aqueous NaCl, this is called brine solution. So in this we have brine as a raw material. Here we pass electricity, so it decomposes. At anode we have chlorine, at cathode we have H2, and near cathode on the right side we have formation of NaOH. Why? Because these two ions are present in the aqueous medium in the solution, so they combine and form NaOH. This is a schematic representation of chlor-alkali process. I would say very important. Then another compound that can be you know used. It is a type of, again it is a type of salt which comes from a type of derivative. So it is formed by action of chlorine on dry slaked lime. So we know slacked lime, CaOH whole twice. Slacked lime, this is also called lime water. Lime water. So when slaked lime reacts with chlorine gas, it forms CaOCl2. That is called calcium oxychloride. It must be written this one, calcium oxychloride. So the name of this bleaching powder is, common name is bleaching powder, chemical name is calcium oxychloride. So it is a very good disinfectant. A white color powder you must have seen, in nearby government offices or in your school. So it is used for bleaching cotton, linen or wood pulp, and it is a good oxidizing agent also. It is a very good disinfectant. Then baking soda is the common name and sodium bicarbonate is the chemical name. Formula is NaHCO3. So I told you in earlier slide that CO3 is carbonate and HCO3 is bicarbonate. So we have bicarbonate. That is why we are having NaHCO3. So how it is prepared? Again, it is a type of salt which is prepared using sodium chloride. Sodium chloride plus water plus ammonia plus carbon dioxide. So it gives ammonium chloride, and this is the baking soda, sodium bicarbonate. So when this baking soda is heated up, when you heat baking soda, so NaHCO3, it forms sodium carbonate, it loses water and it releases a lot of CO2, and this CO2 makes it you know very useful. The CO2 makes it useful because when the CO2 gets released, so it causes the puffness or softness. So that is why it is used in baking, and that is why the name comes baking. So for making, or this is used for for the preparation of baking powder. What Now this is very important. This is baking soda. Baking soda is sodium bicarbonate. Baking powder is different. Baking powder is baking soda plus sodium this tartaric acid salt. That is the difference. Baking soda is hydrogen carbonate or bicarbonate. Baking powder is baking soda plus tartaric acid. So what is the use of baking soda? Baking soda has a lot of applications. So when it is heated up, so this cake becomes soft or spongy because baking powder, when it is heated or mixed with water, the following reaction takes place. Which reaction? This reaction. So when you heat NaHCO3, it releases carbon dioxide, and since this carbon dioxide is released, so that is why we get this softness. This softness is because of, or puffness is because of, CO2 released. So also, since CO2 is released, so it is used as antacid to uh, to deal with acidity, and CO2 is also a very good mm, acts as a fire extinguisher, so it is also used in fire extinguishers. That is the application of baking soda. Now, what is washing soda? So washing soda, again, it is a type of sodium carbonate, but it is having 10 molecules of water. So Na2CO3. Baking soda is sodium bicarbonate, NaHCO3. Washing soda is sodium carbonate, Na2CO3. That is the difference. It is having sodium carbonate decahydrate. Deca means 10 water molecules. So when sodium carbonate comes in contact with moisture or air or water with 10 molecules of water, so it forms Na2CO3 dot NH2O. This is called washing soda. So this is used for manufacturing of glass, cement, soap, borax. It is also a very good cleaning agent, and it is also, this application is very important. This has come in some year, so which I think CBSE board question is this one. Which chemical is used to remove the hardness of water? So that is your washing soda, Na2CO3, sodium carbonate. Now, since in previous slide you have seen this 10H2O, so why it is 10H2O, or wherever you must have seen this copper sulfate dot 5H2O, or we have it will come in next slide, gypsum, etc. So what are these dot H2O? Dot H2O is called water of crystallization. This is called water of crystallization. So it is a fixed number of water molecules chemically attached to each formula unit of the salt. So these are they are fixed. So if it is 10H2, it will only remain 10H2O. And just like we have copper sulfate. So copper sulfate dot 5H2O, that is called copper sulfate. This solution is this crystals. These are very bright blue color because of 5 water molecule. So when you heat it, copper sulfate, So it becomes white. White. Why? Because it loses these five water molecules. So the moment these, on heating, water is removed and turns white. So when you remove this, you heat this copper sulfate or any other salt which is having water of crystallization, so it loses that water molecule and color changes. So this copper sulfate, it comes from blue to white. So this is the transformation. Blue copper crystal, you just heat it, so you get a white powdered substance. This we have plaster of Paris. This is called calcium sulfate, CaSO4 dot half H2O. So this is just half H2O, plaster of Paris. When it mixes with more water molecule, so it hardens and it becomes, gypsum dot 2H2O. So we will discuss it in next slide. So this is plaster of Paris. In short, we call it as POP. POP that we use in our homes to for the decoration for the plaster purpose. So calcium sulfate hemihydrate. Hemi means 1 by 2, 1 by 2 H2O. So 1 by 2 H2O is called plaster of Paris. But when this CaSO4 dot half H2O, it mixes with 1 and half, means 1.5 H2O. So it becomes full 2 H2O. And this 2 H2O is called gypsum. So again, when this gypsum is heated up, when you reverse this one, heat it. So again, you will get this calcium sulfate dot half H2O, that is your plaster of Paris. So on mixing, water with plaster of Paris becomes hard solid mass of gypsum. So this reaction, hemihydrate into 3 by 2 H2O, it forms gypsum. So what is the use of this POP? So it is used in making toys, decoration materials, our homes. We have a lot of false ceilings and so many things are there for the decoration purpose to make surface smooth. So we do use POP for the after that plaster and to make the surface smooth in immobilizing the broken bones. So these orthopedic surgeons, they do use this POP to fix the broken bones. And even dentists, they use it as a, you know, uh, as a module or, sort of to make the structure rigid. So this is just a chemical cycle that means our, environment or our lives are full of acid and bases. What are their applications? So we have washing soda, we have plaster of Paris, we have bleaching powder to get clean water, for baking. So we, nowadays we are surrounded by cakes and so many things are there. So this carbonate, baking soda plays a role. So the entirety of human industry depends on mastering the delicate balance of the chemical. That's equally true. Okay. So one question. There is a substance A. So you have to find the compound A. So there is a substance A which reacts with HCl to produce vigorous effervescence. The invisible gas produced immediately extinguishes the burning candle. So this is very evident. This must be CO2 because CO2, carbon dioxide, is used as a extinguisher. Third evidence is one of the resulting chemical produces calcium chloride, CaCl2. So task is you have to identify metal compound A and balance the structural equation. So you have to identify compound A which reacts with dilute acid, hydrochloric acid to give effervescence, and then the gas which is released is used as a fire extinguisher, and one part is calcium carbonate. So it must be, one part is calcium chloride, so it must be calcium carbonate. Let us see. So this is your answer. The carbonate pathway, the substance is, calcium carbonate. It reacts with HCl to give CaCl2. The gas which is used for the, extinguisher purpose is CO2. It extinguishes flame. So how it this calcium carb the thing is how why there is this comparison is how this carbonate is different from zinc. So both of them, although react in similar way, Zinc reacts with HCl to form ZnCl2. Carbonate reacts with this to form CaCl2. But here is the difference. This zinc releases hydrogen and this carbonate releases H2O. H2O hydrogen gas is highly flammable. So, it will act just opposite. Carbon dioxide, it is used as fire extinguisher. So it diminishes fire, whereas H2 is very, very flammable. It catches fire immediately. So it combusts with a pop sound. So even a small amount of hydrogen, it burns with the, sound, pop sound. Whereas the CO2, it diminishes fire. So that is how they are reacting in a similar way, but their nature is entirely different, exactly different. Okay, so both pathways yield metal salt, but their result, they are very, very different. So that is the beauty of chemistry. So these are few questions for your assignment. So define olfactory indicators. We all know these are based on, smell. What neutralization reaction? I have discussed it in detail. Why do acids not show acidic behavior in absence of water? This question is very good. Why? Because there is no H plus in dry state. Why does distilled water does not conduct electricity? Again, same, because there are no free ions. What do you mean by water of crystallization? It is the amount of water molecule present in a one crystal, one formula unit. Formula unit is the keyword. One formula unit of any, salt. What is chloralkali? I have discussed it in so much detail. So even if this question comes in 3 or 5 marks, you can write it properly. You have so much of detail regarding chloralkali process. What happens when solution of sodium bicarbonate? You already know. It releases CO2 and that is why it is used for the baking purpose. So that's it from my side. So chemistry is a, very good, I would say, being my subject, it is a very good part of science. And of course, it is not just a study of microscopic equations, it has so many things to do with uh, around means in our atmosphere and in our everyday life. So if you found this video helpful, don't forget to like and subscribe or share my video. Thank you so much for being with me.